All right, so this part of class, we are going to talk about the real number system and classifying numbers. We're not really going to be doing any computation math. You're not figuring out anything. You're just classifying where numbers belong. So what type of number is it? Okay, so you're going to fill in these definitions as we go. Now, when we look at numbers, most of our numbers fall into a category what we call real numbers, okay? That's up at the top. They're real numbers. Now, there are numbers that are not real, okay? And I kind of mentioned that in the first half of class. They're called imaginary numbers. As 7th graders, we don't really care about imaginary numbers yet. You will learn about them when you get to like Algebra 2, okay? So we do, at this point, what we care about is the real numbers, okay? And under real numbers, it kind of falls into two categories. We either have rational numbers or irrational numbers. Okay? Now, rational number. Okay, you need to write this down in your notebook. Rational numbers are fractions. Any number that can be written as a fraction is a rational number. Okay, Travis, I know you just joined back in on the Zoom. I did put the class ID for Hello Smart in your GoGuardian chat. So you can enter that in. Okay, now I also want you to add, it's not only fractions, it's also terminating or repeating decimals. Okay, so it's fractions, it's also terminating and repeating decimals. Okay, so if a number is a rational number, that means I can write it as a fraction or it's a terminating or repeating decimal. And terminating decimal just means it ends, and I'll show you examples of all of these. Repeating, obviously, it means it repeats. Okay? Now, if it's not a rational number, then we would call it irrational. Okay, and irrational numbers are numbers that just really don't make a whole lot of sense. They cannot be written as a fraction. Okay, so if it's an irrational number, it cannot be written as a fraction. It is non-terminating and non-repeating decimals. So I'll give you a second to write that down. Okay, it cannot be written as a fraction. It's non-terminating and non-repeating decimals. Okay, now if I'm an irrational number, that means I might be a number like pi. Okay, that number pi is an irrational number. If we think about pi, remember it's 3.1415, blah, 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 blah. It keeps going on. It doesn't end. It doesn't repeat. Okay, it's just really not a nice number. There are other numbers, like the square root of 2. Okay, if I did the square root of 2 in my calculator, it is not a nice number. The square root of 2 is, hang on, it ends up being like 1.414213562. And again, it doesn't end, it doesn't repeat, so it's not very nice. Okay, the square root of 3 is not a nice number either. Okay, so those types of numbers are what we would call irrational numbers. Now, rational numbers are nicer. They make more sense to us. irrational numbers don't really make sense. Okay? Now, if they're a rational number, then they could be these other things also. They don't have to be, but they could be. Okay, so we're going to start down here at the bottom, a natural number. Okay, a natural number is a counting number. Okay, so I'll write that down. When you were little, like when you were 3 and you started counting, how did you start counting? I see some of you doing this. Absolutely. You used your fingers, right? You went 1, 2, 3, 4, 5, and so on and so on and so on. Now, when you were little, you maybe only went to 10 because that's all the more fingers you had. Maybe you used your toes and went to 20, okay? But we know that they can keep going, okay? Natural numbers are counting numbers, starting with 1. So it's 1, 2, 3, 4, and so on and so on and so on. 5, 6, 7, 8, 9, 10. 592 is a counting number, okay? Because we could count there. Now, the nice thing about natural numbers, there's no fractions or decimals. So you can add that to there. If it's a counting number, it's not going to be a fraction or a decimal unless you can simplify it to a nice whole number. Okay. Now, you got a little bit older and you started kindergarten, and all of a sudden you learned that there's another number before 1. And we could actually start at 0. Okay, and that was kind of a big deal that there's a number 0. So whole numbers are counting numbers plus 0. Okay, so the only difference between a counting number and a whole number is now we start at 0. So whole numbers would be 0, 1, 2, 3, 4, and so on. Okay, so there's obviously a lot more. I can't list them all. Okay, but it starts at 0. Again, with whole numbers, there's no fractions or decimals. No fractions or decimals in whole numbers. They're just nice numbers, but they start at 0. Okay, then you got to about 6th or 7th grade and we learned about integers. Okay, integers are positive and negative whole numbers. Okay, again, there's no fractions or decimals. So no fractions or decimals in integers. It would be our numbers like -3, -2, -1, 0, 1, 2, 3, and so on in either direction. We could go more negative, we could go more positive. But again, they're nice whole numbers. Okay. Now you notice that some of these numbers show up in more than one category. Okay. All of these numbers, integers, whole numbers, natural numbers, they're all part of rational numbers. Okay. So let me give you some examples that we're going to write down. Okay, hang on a second. I'm going to put it in a different color. So I might say that a number like 7 is a natural number. you can add that to that category. 7 is a natural number because I could naturally count to 7. Okay, 7 is also a whole number, so it would go in that category. The number 7 is also an integer. Okay, now the number 7 is also a rational number. Okay, 7 is also a rational number because I could write it as a fraction, right? I could write it as 7 over 1. So therefore, it's a rational number. Now, if it's rational, it cannot be irrational. Numbers are either one or the other. They're either rational or they're irrational. They cannot be both. Okay? Now, if I give you a number like 1/2, 1/2 is a fraction, so therefore it's a rational number. However, I cannot put 1/2 in any of those other categories because integers, whole numbers, natural numbers, they cannot have fractions. Okay? I could give you another example like -15. Okay, -15 is a rational number because I could write it as a fraction. -15 is also an integer. So I could put it in that category. But -15 is not a whole number because whole numbers are not negative. Okay, so that only fits in 2 categories. Okay. All right, so what we're gonna do is we're gonna play a little game called Name That Number, okay? So you need your notebook in front of you so you can look at these definitions, okay? And I'm gonna show you a number, and I want you to put a check mark in every box that you think it would belong, okay? So I'll show you the first one together, okay, and what we would do. Okay, so on the first one, okay, so everybody needs to be on Hello Smart right now so that you can see this. The first number is 8, okay? We would want to place that number in all the categories that it belongs. So I would start with rational number. Can I write 8 as a fraction? I would say yes. So I would put a check mark in that box because that's a true statement, okay? It is a rational number. Is 8 an integer? Positive or negative whole number? I would also say it is that. Is 8 a whole number? Yes. And is it a natural number? Can we naturally count to 8? Yes. So the number 8 would go in all 4 of those categories. Now, it's not an irrational number, so I can't put it in that category. Does this make sense? Does that make sense to everyone? Okay, so I'm going to give you another number, and then I'm going to make it an activity. You're going to end up seeing lots of check marks show up on your screen, okay, because everybody's going to write on the same screen. We haven't done it this way before. We'll see how it works. Okay, so 16.3 is the number. Hang on. Mine is taking a second to load. Okay, go ahead and put a check mark in every box that you think that belongs in. Make sure you choose the pen first. Okay, so we have some mistakes here. Okay, 16.3 is what I would call a term. Don't scribble all over the screen, please. Just put your one check mark and be done. Okay, 16.3 is what I would call a rational number. This is only rational. Okay, it is rational because it is a terminating decimal. It's a decimal that ends. Okay, so if you put a check mark as irrational, irrational means the decimal does not end. Okay, stop writing on the screen. Stop writing. The next one I'm going to make it all individual because too many people like to keep writing. Okay, so this one would be rational only. Does that make sense? Okay, it is not an integer because integers cannot have decimals. It's not a whole number because it can't have a decimal. It's not a natural number. We don't naturally count to 16.3. Okay, let's try another one. The next number is negative 11. Let me make this an activity for you. Okay, and this one is just on your own. I want you to put a check mark where you think that number belongs. In all the categories that you think it belongs, negative 11. Okay, and I'll give you a hint that this only goes in 2 categories. It only goes in 2 sets. Okay, so if you split your screen and look at the Zoom screen, you should have put this as a rational number and an integer. It is only a rational number and an integer. Okay, it's rational because I can write it as a fraction, negative 11 over 1. It's an integer because it's negative. You guys, it cannot be a whole number. Whole numbers are not negative. So some of you checked whole number. Whole numbers can't be negative. Some of you checked irrational. This is a nice number. Negative 11 makes sense. If they're nice numbers, that means they're not irrational. Okay? All right, let's try another one. Pick the category for this number. I'll make it an activity for you. So you should be able to click start. Put a check mark in, and I will tell you that this only belongs in 1 set. There's only 1 spot for this number. So go ahead and click start. Put a check mark where you think this belongs. Okay, so if I tell you that this number only belongs in 1 spot, that means it has to be either rational or irrational. Does this number make sense? Is it a nice number at all? Not really, okay? It's kind of a messy number. So it is an irrational number. So you should have check marked irrational. Okay, it is not a nice number. It does not end. That's why it has the 3 dots at the end. It's not repeating. So it's irrational. Okay, let's try another one. Here's the next number. Okay, 0.5 repeating. Now, this is a repeating decimal. So where would you put the repeating decimal? .5 repeating. And again, it only goes in 1 spot. where should we put that number? This one's repeating, so look at your definitions. Where would we put a repeating decimal? Okay. This one you should have put as a rational number. This is rational. Repeating decimals are rational numbers. Okay, so if it's repeating, it's rational. It cannot be an integer, whole number, or natural number though, because they don't have decimals. Okay, here's the next one. Yep, our homework is going to be kind of just like this. Okay, we have a fraction. I'm going to make it an activity, so you can click start. It's -5/8. Put that in all the categories that you think it belongs in. And it only belongs in one. This only belongs in one category. Okay, you should be clicking start on your screen if you haven't. So Carson Worms, you need to click start. Okay, so lots of you have this correct. This is a rational number. Okay, any number that can be written as a fraction is rational. This is a fraction, so therefore it's rational. Okay, this is actually a nice number. It doesn't have random decimals. Okay, so rational is where that one would belong. Okay, here's the next one. Again, it's 0.56. The decimal ends, so that means it terminates. So go ahead and click start. Where would you put that decimal? And again, it only belongs in one category. Okay, this is a nice decimal though, so some of you might change your mind. This is a nice decimal. It ends. It terminates. So think about where a terminating decimal would go. Okay, if you did this one correctly, you should have placed it as a rational number. Okay, that is a rational number. Some of you wanted to put it as irrational, but irrational are not nice decimals. This is a nice decimal. It stops. Irrational is not nice. Okay, irrational is messy numbers. This one isn't so bad. Okay, here's the next one. This one's kind of a tricky one, so be careful. Okay, 9/3. Go ahead and click start and put it in all the categories that it belongs. It belongs in more than one category. It's a fraction, so think about where that goes, but it can also be simplified. So then think about where it would go. If you simplify that fraction, where else would you put it? Okay, and I will tell you that it actually goes in 4 categories. Okay, so 9/3 is a rational number because it's a fraction. But if I simplify 9/3, that is just 3. Well, I know that I can naturally count to 3. 1, 2, 3. Okay? And if it's a natural number, you guys, it's everything in this side. It's a whole number and it's an integer. Okay? Now, if it's rational, it cannot be irrational. So we would never check mark irrational if it's rational. Okay, let's try another one. Here's the next one. Negative 121. Negative 121. Where would that go? We'll tell you this one only goes in 2 categories. Okay. Okay, so this is going to be the last one we do. This one is a rational number. It's also an integer. Okay, we cannot naturally count to negative 121. Whole numbers can't be negative, so it just fits in those 2. Okay, so I'm going to stop this activity. Oops. Okay, and you guys can go to Canvas. So you